Today, let's talk about factoring. That last time we talked a little bit about factoring. Remember that problem we had with x? Let's just show this problem again. X plus xy equals 1. And if I say solve this equation for x, well, I have to factor the x out of this expression. In other words, I have to turn it into this. Same equation, just I've factored the x out. And now I can divide both sides by that coefficient to give me the answer. X equals 1 divided by 1 plus y. Okay, so this is an example of factoring. Now, there's three main ingredients to factoring. One is the first one you look for, a greatest common factor. If I give you these two numbers, what's the greatest common factor?
Wouldn't that be...
You're looking for a number that divides evenly into both of these, and the biggest number we can find.
Isn't it 2?
Yes. Yes. In other words, I can divide both of these terms by 2 and write this expression like that. 2 times 3 plus 4 is the same as 6 plus 8. Okay?
Okay.
Now let's introduce some variables. If I say 6x squared plus 8x, find a greatest common factor for this. Well, we know that 2 is the number part. Can I take a variable out?
Yes.
Yeah, I can take at least one x out. And what I'm now going to do, in other words, once I've found my greatest common factor, I'm just going to divide both of these terms by that. So 6x squared divided by 2x is what? What's that equal to?
3x.
Got it. And what is 8x divided by 2x?
4. No, 4. Just 4.
Okay, good. So that's greatest common factor. In other words, I have factored this expression into the product of these two things. And one good habit to get into is when you're doing this, this is a skill that's going to be, if I had to name the #1 algebra skill that you're going to need over the next 4 years of school, it would be this one. Factoring expressions. So let's make sure we've done it correctly. If I multiply these two things back together again, I multiply that times that, which gives me 6x squared. And then I multiply that times that. It's not quite every term by every term, but in a sense it is. 8x. So I end up with the same thing I started with. And that's a key test to determine whether you have factored something properly, is always multiply it back together again and see whether or not you get what you started with. Now, your next question might be, well, why do we have to do this? If I give you an equation instead of an expression, and I say that 6x squared plus 8x is equal to 0. Well, I don't have a lot of ways to solve that. When I'm adding two things together and they're equal to 0, x could be most anything. I mean, I wouldn't know how to solve that. But if I can factor that expression, and I can get two things multiplied together that are equal to 0, it's a whole different story. If I get two things multiplied together that are equal to 0, then one of the things has to be 0. Because that's the only way you can multiply stuff together and get 0, is if one of the things is 0. If I say x times y times z equals 0, one of these three letters has to be 0. Okay? Huge principle in algebra. Huge. So that's why factoring is so important. It's because what you're doing is you're taking, instead of the sum of two things equal to 0, you're taking the product of two things equal to 0. Now, if this is true, if 2x times 3x plus 4 equals 0, well then it means either 2x is equal to 0 or 3x plus 4 is equal to 0. And those are two equations that I can solve. Solve this one for me. What's x equal to? 0. What's x equal to in the second one?
I would still say 0.
No, solve it. We've been working with solving, in other words, this is a simple equation in one variable, which means we can solve it for a number. So what's the first step?
-3.
No. What's happening here? Remember, we're trying to reduce that down to x equals something. Well, let's isolate it one piece at a time. Am I going to get rid of the multiplier of x, or am I going to get rid of something that's being added to it?
Something that's being added.
Okay, so what's the first step?
-4.
Okay, so what's the next line?
3 times x equals 4.
Minus 4. There you go. And the next line, now I'm going to divide both sides by 3.
So x equals, I don't know.
Well, divide -4 by 3. In other words, I'm going to write a -4. I'm going to divide it by 3. So it's -4/3. So we were able to solve the problem. In other words, I now know that there's two possibilities for x. Either x is equal to 0 or x is equal to -4/3. And if I look at the original equation, I can see that both of those are going to work. In other words, either x is equal to 0 or x is equal to -4/3. If I plug x equal to 0, yeah, 6 times 0 plus 8 times 0 is equal to 0. So the x equal to 0 works. And if I try that solution, it will work also. So what we've now we're able to solve quadratics, which until we learned about factoring, we had no way to solve. Now, this is the easiest kind of factoring, where you're merely factoring out a greatest common factor. Let me give you a few more of these. Factor that by greatest common factor. Hold on, let me erase some of this other stuff. I want to separate that into two things. What's the greatest common factor?
3.
Just 3 or 3 with a variable?
Oh, 3x.
Okay, what's left over? When I say what's left over, I mean, okay, after you've factored out 3x, what do you have remaining?
3 times...
What would I have to write there such that these two multiplied together would give you that?
Oh.
not 3x, because if I multiply those two together, I get 9x squared.
So 3x squared.
You got it. And then what's the second term?
3x, right?
Now I'm dividing everything by 3x.
It would be 1.
Minus 1.
Minus 1.
Okay? And notice, let's do our check. Let's multiply these two things back together again. I get 9x cubed minus 3x, which is what I started with. That tells me that I have solved it correctly. All right. So that's greatest common factor. The second time of factoring is the hardest of all. And this is what I spend most of my time with students. I'm going to give you an easy one to start with here. Is there a greatest common factor in this expression?
No.
No, because 10 doesn't go into 1, 10 doesn't go into 7, and x doesn't go into 10. So I can't use greatest common factor here. However, there are two linear terms that multiplied together will give you that. Now, have you heard of something called the California method?
Nope.
Diamond method?
Nope.
Good. I'm going to teach you my method then. My method is the simplest one. Much easier than what they tend to teach in school. In fact, a lot of schools have gotten away from teaching the California method because it just confuses people. Okay, here's my method. First of all, this is a quadratic expression. And it's a quadratic that has a constant. And whenever you have a quadratic, in other words, if I took away the 10, I could pull out a greatest common factor. It would be x. Right? But if I have the 10 in there, well, now there is no greatest common factor. So we'll have to use my method. Okay, I'm going to call this a level 1 quadratic. Level 1 being the most elementary kind of quadratic that we're going to have to learn how to factor. We'll spend a lot of time on learning how to factor this. But you basically want to just memorize this as step by step. Okay? First step, separate that. And you separate that by that and that. In other words, I'm going to break up this quadratic into two linear expressions. And I'm going to get to the answer before I tell you the method, just so you can see. Multiply these two things together. Using FOIL or ET, you know you have to multiply every term by every term. So what do you get when you multiply them together?
You get 10x squared.
Hold on. First of all, you multiply those two terms. What's x times x?
X squared.
So just x squared. Next, you multiply that times that. What do you get?
2x.
Next, multiply that times that.
5x.
And finally, multiply the two numbers together.
10.
Simplify that.
2. No, wait, hold on. 7.
Hold on. How many x squareds do we have?
2.
Just one. Just one. How many x's do we have?
We have 1, 2, 3. No, just, yeah. 3.
What's that equal to? What's 2x plus 5x?
That would be just 7x.
Okay, and then finally we only have one number. Okay, so what we have found out here is that we're doing the reverse of multiplication. We're taking x plus 5 times x plus 2, which results in what we started with, and we're breaking it apart. We're going backwards. So that's what factoring is all about, is going backwards. Now, how do we do it? Let's go through all steps here. As I said, the first step is to break up the x squared. You can only get x squared by multiplying x times x. So that's step one. And that's pretty simple. Okay? Step two is to determine what both signs are going to be. Are they going to be plus minus? Are they going to be minus plus? Are they going to be plus plus? Or are they going to be minus minus? Well, to figure out what, we look at the sign that's on the constant. The constant is 10. It has a plus sign in front of it. That tells me that both signs have to be the same. I could not produce that plus 10 unless I either had minus minus or plus plus. So I know the signs have to be the same. I look to the middle term. It's got a plus on it. That means they have to both be plus. If that middle term had a minus on it, it would have to be minus minus. You with me? So that's the second step, is to determine what both signs are. The third step is relatively simple. It's factors of 10, which means two numbers that multiply together to 10, that are add to the middle coefficient. Well, what factors of 10, what two numbers that multiply to 10 add to 7? 5 times 2. And there's my answer.
That's quite a confusing answer.
Well, it's a confusing process, but this is the simplest it's going to get. Let's do more. Let's do more, because this is something we just can't, you're not going to be able to avoid. Let me change some numbers here. First step is the same, right? X and X. What are both signs? What are both signs? In other words, I need to figure out what both signs are going to be. Are they going to be the same or different? They're both going to be the same, right?
Yeah.
They don't have to be plus yet. Because if I had a minus times a minus, I'm going to produce this plus right there. So I could be minus minus, but because I have a plus in the middle, it's got to be plus plus. Now, what's the final step? Factors, say it out loud.
Factors.
Of 25.
So 5 and 5, yeah.
You got it. That's it. 5 and 5. Okay?
So that's what it's going to get.
What's that?
And that's the simplest it's going to get.
This is the simplest it's going to get. Now, let me go back up and change it slightly. Now, step one is the same. In what I call elementary quadratic, step one is always the same. It always is going to break up into x times x. Step two, determining the signs. Well, this plus sign tells me that they're both the same, but this minus sign tells me that they have to both be negative.
That would be both negative, and then 5 still.
Right. In other words, I still want factors of 25 that add to the number 10. Well, that's still 5 and 5. And that's how that breaks up. And if you multiply this back together again, you will get this. That's our whole goal, is to break it apart. Okay, you with me?
Yeah.
Okay, so far actually pretty easy, right?
Pretty easy.
Well, let me give you another one. Tell me step one.
Okay, step one, put an X there and an X in the second box.
Step two.
Step two is to put negative signs after the X's.
Very good. Step three. Verbalize it.
Okay, so 27.
Factors of 27 that have to do what? They have to add, because that's a plus, to the number 12. Not to minus 12, but to the number 12. Well, let's list factors of 27. In other words, part of this process is going to be you're going to have to be able to come up with factors of this constant. Well, how can I break that down? Can I do anything to 27? Can I break 27 in half?
No.
Can I break it in thirds?
Maybe.
Yeah, 1/3 of 27 is 9. So what's this number have to be?
3.
Okay, those are two factors that add to the number 12. That's my answer. 9 and 3. And in this case, it doesn't matter where I put the 9 and 3. I could put the 3 over here and the 9 over there. It's still going to multiply back together to give me that. Okay? So, as long as this is a plus sign, we're in good shape, because that tells me that my signs have to be the same. So for the rest of the session today, let's work on some more of these. And then next session, we'll deal with what happens if this is a minus sign. So let me make up some more here. Think. Factor that for me.
Okay, so 2 X's on both sides, like we always do. Then it would be a plus to get those 2 plus signs. And then it would be 3 and 5.
Very good. All right, since you're good at that, let's go ahead and jump forward and try a minus sign here. Let me think for a second. Okay. First step.
The 2 X's, like we always.
Now, the fact that that's a minus sign in front of the constant, I can't produce a minus sign unless I'm multiplying a plus number times a negative number, right? If I've got 2 negatives, I'm going to get a plus sign. If I got 2 positives, I'm going to get a plus sign. The only way I can get a minus sign is if I have opposite signs.
Oh, no.
It's all right. Listen up. So I've done step 2 because x minus and x plus is the same as x plus times x minus. So I don't care where I put my plus and my minus in this case. I just know that the signs have to be opposite. Now, the third step is still relatively simple. It's factors of 15, but they have to subtract to the number 2, not add. They have to subtract because that's a negative. So what factors of 15 subtract to the number 2?
Wouldn't it still be 3 and 5?
Okay. Now, there's 1/4 step because we are dealing with a negative sign here. And that's where does the 5 go and where does the 3 go? Take the bigger of your factors, 5, and put it with the sign of the middle term. Right there. The middle term has a negative sign in front of it. Put the biggest factor there. The other one goes there. Those are the factors. If you multiply those two back together, you'll end up with this quadratic. So the only difference when you have a negative sign is there's 1/4 step. And that's figuring out which number goes with which sign. Because notice that when the signs are the same, if it's negative, negative, it doesn't matter which number goes where. It's the same meaning. But when one sign is positive and the other sign is negative, then it matters which number goes which. If I put the 5 over there, in other words, if I switch them up and I multiply these two together, I'm going to get this, not what I started with. So that 4th step is a critical step in that you put the number with the proper sign. And the bigger number always goes with the sign of that term. Because notice when we multiply the middle term, let me say a last few things here. When we go to check our answer, I don't need to really check that. I know how to break up x squared. It's x and x, right? So that's no big deal. I don't need to check that. I know that I got this answer by finding factors of 15. But the one term that I do need to check is the inside term. That term right there. Well, how do you get the inside term? You get it by multiplying the insides together and the outsides together. Probably why they teach FOIL is because this is the O and the I of FOIL. Then add those two terms together, you get 2x. Our middle term is correct. But when I'm checking, that's all I need to check is the middle term. I do not need to check this first term. I don't need to check this third term. Just the middle term, and I use what I call my double smiley face method, where I just draw a branch between the inside terms and the outside terms, multiply them together, add the result, and that is your middle term.
You could call it the upside down rainbow.
You could call it anything, but whatever helps you memorize it. In other words, if that helps you memorize it, use that. Frequently, that's the trick to memorizing stuff, is to come up with a good association for it. All right, we'll do that. We'll do it for today, and then next time we're going to pick up on more factoring. We'll practice more that have negative signs and with the constant. Okay? But all in all, you're making pretty good progress, Garrett. I'm pleased.
Well, thanks.
Yeah, you're welcome. Talk to you next time.
Okay, bye.
Bye-bye.